For pre-calculus sections 1 and 2 of chapter 3, I have grouped together. Now we're going to talk about using the one-to-one property. So there's a one-to-one property for exponential functions, which you see on the screen here. And there's also one for log functions, which is in this list right here. So let's go back up here. One-to-one property is basically telling us, obviously, a has to be greater than 0. A can't equal 1 because that's the rules for exponentials. If I have two exponentials equal to each other that have the same base, then their powers have to be equal. Well, if they set it up that way, that's great. So if they said 2 to the x equals 2 to the 5, and we could just say, oh, well, that means x equals 5, that's wonderful. But if you look at our examples, that's not quite how they set it up, is it? So what I usually do is I look at the base that has a variable in its power. How can I break 9 down into a 3 base? Well, 9 is 3 times 3. So I could say 3 squared, that's a 3, is equal to 3 to the x plus 1 power. Now, since my bases match, there's no extra stuff in here anywhere, right? Then I can say 2 equals x plus 1. Just for the record, those 3's don't actually cancel out. That was just my visualization of how this works. We solve the equation, minus 1 minus 1. 1 equals x. Okay? So x equals 1 is our answer. Let's double check it. 9 equals 3 to the 1 plus 1. This is a question mark because we're checking. 9 equals 3 squared, and that is true. So x equals 1 is the correct answer. Now, fractions usually get us in a little bit of trouble. That's one of the reasons it's good to have it in our examples. 1/2 to the x power. Well, I'm not real sure how to change 8 to the to a 1/2 base. That's not entirely true. I do know how. I just don't expect you to know how off the top of your head. Anytime I have a fraction like this, if I pull that bottom piece up, it would be to the negative x. Now, I do know how to change 8 to a base of 2. So 2 to the negative x equals 2 to the 3, because that's 8, right? So if I set my powers equal to each other, negative x equals 3, then x equals negative 3. If I have 1/2 to the negative 3 power, I want to know if it equals 8. Well, the negative flips it over. That's 2 to the 3rd over 1 to the 3rd, which is definitely 8. Yes. Okay, so that's how that works for exponentials. And then we have some properties of logs. Now, we don't have this long list for exponentials because our exponent rules have been taught to us so many other times that we don't have as many of them in here. We will talk about them. Log base a of 1 equals 0. Anytime my argument is 1, my power is 0. That's the way it works. What power turns everything into 1? 0 does. Anytime my base and my argument match, my power is 1. Anytime my base and my base of my argument match, whatever power is on my argument is my answer. Same thing works over here for exponentials. If my base matches the base of my log, then my argument is my answer. I know that's a kind of weird one. We'll get to it. And here's my one-to-one. This is what I was actually looking for. If I have log base a of x and log base a of y, my bases match. There's nothing extra, then my arguments have to be the same. So looking at these examples, simplify log base 4 of 1. That's basically saying 4 to what power equals 1, and we know the answer to that is 0. See how we have here square root of 7 and square root of 7? This is like saying square root of 7 to the 1 power. So the answer to that is 1 because my base and my argument match. Here, if my base and I have a log to the same base as the power, the argument is my answer. All right. Down here, one-to-one property. Log base 3, x, and 12. So x has to equal 12. That's how it works. Didn't have to solve anything for that one. For this next one, log, which is a base 10, remember, of 2x plus 1 equals log, which is a base 10 again, of 3x. So I have 2x plus 1 equals 3x. If I subtract 2x, then I have 1 equals x is the answer. Next, log base 4, log base 4. So I'm going to say x squared minus 6 equals 10. Since there's no x value, I can use the square root properties here. So I have plus 6, x squared equals 16. When I take the square root, I get plus or minus 4. Just a quick note, you should always check these to make sure they actually work out. These, if I plug into the x squared, they're both going to give me 16 regardless, aren't they? So that's definitely okay. All right. Properties of natural logs follow the same properties of regular logs, except we have log base e. So here, log base e of e is 1. Log base e of e to the x is x. These work the exact same way, guys. All right, this one, you have to kind of think about this. Natural log, which is log base e, of e to the negative 1 is negative 1. Here, because I have e to the log base e of 5, it's 5. Ln 1 is equal to 0, so you have 0 divided by 3 is 0. Ln e is 1, so I have 2 times 1. All right. Next, we're going to get into transformation of graphs. Let's cut it right there, and we'll come back for that.